welcome to my channel. So in this video we are going to see the problems related to the series RLC circuit. Okay, so these problems are very important problems. So you see the same problem, it is asked in December 2017 and no, May 2019 and December 2012 and every year this May 2008. Okay, so every year in the from this topic there are some problems it will come. Okay, so we are going to see the problem related to the series RLC circuit. Okay, so the first question, compute the Q of series RLC circuit with R equal to 10, L equal to 0.04 Henry and C equal to 1 farad. Find the bandwidth and resonant frequency and half power frequency. Okay, so these are all the things. So in this you see, so Q means quality factor. Okay, so series RLC circuit, first okay, what is series RLC circuit? So in this the resistor, inductor and capacitor is connected in series combination with some input voltage. Okay, so that is said to be the series RLC circuit. And this RLC circuit it is a resonant circuit. Okay, resonant circuit. So for this RLC circuit, the resistor value, inductor value and the capacitor value is given. So what is the question means? Compute Q. Okay, what is Q? Quality factor. Okay, quality factor of that particular RLC circuit we have to calculate, and also calculate bandwidth. Okay, so what is the bandwidth of the series RLC circuit? Resonant frequency and half power frequency we are going to calculate. So this is a 6-mark question. So these type of problem, it's an important problem. Okay, so first one we are going to write the given data. Okay, so what are the given data? Resistor R equal to 10 ohm, L equal to 0.04 Henry, C equal to 1 farad. Okay, so the first thing, in order to calculate the quality factor, first we should know the resonant frequency. Okay, so that's why first one we are calculating the resonant frequency. Okay, so the resonant frequency it may be in two things, that is omega naught or f naught. That is the omega naught is said to be the resonant frequency in radians. The f naught is said to be resonant frequency in hertz. Okay, so here we are calculating the resonant frequency omega naught. So what is the resonant frequency of the series RLC circuit? So whose formula is 1 divided by square root of L into C. Okay, so you just substitute the value of L and C. Upon 1 divided by square root of, what is the value of L? 0.04. And what is the value of C? It's a 1 farad. Okay, so 1 farad. So you just substitute and find out the answer. The omega naught is 5 radians. Okay, so resonant frequency we calculated. Okay, next one, we are going to calculate the quality factor Q. Okay, so this is the formula in order to find the quality factor of series RLC circuit. Okay, so there are 3 formulas are there. In order to find the quality factor, 3 formulas are there. So we may use any formula. So what are the formula means? The first one is omega naught L divided by R. Okay, the another one is 1 divided by omega naught CR, or otherwise 1 by R square root of LC. So we may use any one of the formula in order to calculate this quality factor. In any method we will get the same answer. Okay, so the quality factor of the series RLC circuit is omega naught L divided by R. Okay, so we have to substitute the values. What is omega naught? So from the previous step, omega naught we calculated as 5 and the L value is 0.04 and the R value is 10. Okay, so you just substitute and you have to find out the answer. The quality factor is 0.02. So what is the unit for the quality factor? Quality factor, it is said to be the just number. Okay, no unit. So that's why the quality factor we calculated is 0.02. Okay, this is the thing. And the next one, bandwidth of the circuit we have to calculate. So the bandwidth of the given circuit is calculated as the bandwidth is equal to R divided by 2 pi L. Okay, so this is the bandwidth formula in hertz. Okay, so if we want to find out the bandwidth in radians means, so you just that multiply this hertz with 2 pi. So that's why we will get the formula R divided by L. Okay, so this is the R by 2 pi L is the bandwidth formula in hertz. Okay, so the same bandwidth in order to find out in radians means the formula is R divided by L. Okay, so first we calculated in hertz also, in radians also. Okay, so in problem, in some problem they are mentioning it as find bandwidth resonant frequency in hertz they will ask, but here just find bandwidth resonant frequency. So we may calculate either hertz value or radians value. Okay, that's why we calculated both the values. Okay, so the bandwidth is equal to R divided by 2 pi L. So just substitute the value. R is 10, L is 0.04. So we calculated the bandwidth is 39.78 hertz. Okay, so this is the bandwidth in hertz. So if you want to find out the bandwidth in radians means you just multiply this hertz answer with 2 pi, or otherwise you use the formula. What is the formula? This R by 2L. Okay, instead of this 1 by 2 pi, just simply R divided by L. Okay, so if we are calculating, the answer is 250 radians. Okay, this is the bandwidth. Okay, so next one, the question is half power frequency. Okay, so what does it mean by half power frequency? That is, in the series RLC circuit, in two frequencies, the frequencies at which the series RLC circuit, the power at the series RLC circuit reaches half of the maximum power. Okay, that's why that the two frequencies are said to be half power frequency. Okay, so there are two cutoff frequencies there. One is lower cutoff frequency, another one is a upper cutoff frequency. Okay, so what is the lower cutoff frequency formula? Means the lower cutoff frequency equal to 1 divided by 2 pi into minus R by 2L plus 1 by 2 square root of R squared by L squared plus 4 divided by LC. Okay, so this is the standard formula in order to find out the lower cutoff frequency of series RLC circuit. Okay, so the higher cutoff frequency is that 1 by 2 pi R by 2L plus the same value. Okay, so what is the difference between this lower cutoff frequency and upper cutoff frequency means, so here 1 minus it will come. Okay, in lower cutoff frequency. In upper cutoff frequency, this is not a minus, it is a plus. Okay, so that is the only difference between the lower and upper cutoff frequencies. Okay, so we will just substitute the value of R, L and C values. So if you are substituting and if you are calculating in Cal C means, we will get the answer is the lower cutoff frequency equal to 0.015756 hertz. Okay, so it is nearly 0 hertz. The lower cutoff frequency is, so you see, this is the 0.015 hertz. So it is a nearly, 0 hertz. Okay, then we calculated the upper cutoff frequency. So what is the difference? So in this formula, here in lower cutoff frequency, here one minus will come, here plus will come. Okay, remaining and all the same formula. So you just substitute, and if you are calculating, the answer is 39.805 hertz. Okay, so this higher cutoff frequency we calculated and the lower cutoff frequency we calculated. Okay, and this bandwidth, you know what is meant by bandwidth means, the bandwidth is said to be the difference between this higher cutoff frequency and this lower cutoff frequency. So we just subtract 39.805 minus of 0.0157 means we will get the same answer, 39.78 hertz. Okay, so that is also another one method in order to find out the bandwidth. Okay, instead of using this formula, in order to find out the bandwidth, we have to calculate upper cutoff frequency and lower cutoff frequency. If we are subtracting that two frequency means we will get the bandwidth also. Okay, that is another one method. So in this way, we have to calculate the answers for these things. Okay. So what is the resonant frequency formula? Resonant frequency formula is 1 by square root of LC. Okay. So you just remember. And the quality factor, what is the formula? Omega naught L by R. What is the bandwidth formula? In hertz means R by 2 pi L. In radians means simply R divided by L. And the lower and upper cutoff frequency is 1 divided by 2 pi into minus R by 2L plus 1 by 2 square root of R squared by L squared plus 4 by LC. In upper cutoff frequency, instead of this minus, in that case, plus will come. Okay, so it is a upper cutoff and lower cutoff frequency in hertz. Okay, so these are all the things. So it's an important question. Okay, but similarly, here you see two more problem. A series RLC circuit has R equal to 1 kilo ohm, L equal to 1 millihenry, and C equal to 1 picofarad. Find the quality factor of the load. Okay, so it is a May 2019 question. Okay, so in a series RLC circuit, always problem will come either in 2 mark or 8 mark. Okay, 8 mark question. Okay, that is simply resonant frequency, or they will ask resonant frequency or quality factor or something they will ask. Okay, so in this thing, RLC value is given. So the question is only we have to calculate the quality factor. Okay, So already you know the quality factor formula. What is the quality factor formula? Omega naught L by R. Okay, in order to find out this quality factor, first we have to calculate the value of omega naught. Okay, so what is omega naught? Omega naught is a resonant frequency in radians. So what is the formula for omega naught? 1 divided by square root of L into C. Okay, so you just substitute the value of L and C. If you are calculating the omega naught value is 31.6 into 10 to the power 6 radians. Okay, this is the omega naught value. Okay, and substitute this omega naught value in quality factor. Okay, in quality factor the omega naught is 31.62 into 10 to the power 6. L value is 1 milli. So milli means you know, milli means 10 to the power minus 3. Okay, then pico means 10 to the power pico means 10 to the power minus 12. Okay, so here R value, what is R? 1 kilo ohm. So 1 kilo means 10 to the power plus 3. Okay, so you just substitute the values and find out the answer means we will get 31.62. Okay, this is the one. So this is a one way of calculating the quality factor. Okay, so instead of these two things, we may calculate the quality factor using another one formula. Okay, so already I told that is the quality factor. In order to calculate the quality factor, three formulas are there. One is omega naught L by R. Another one is 1 divided by omega naught CR. The third formula is 1 by R square root of LC. Okay. So in this all resistor, inductor and capacitor values available. No omega naught is available. Okay. So you may choose in order to calculate the quality factor. In this problem RLC. Okay. Three values are given. So by using this direct formula, you may calculate the answer. Okay. So you substitute the value of RLC, we will get the same answer, 31.62. Okay. So if you are using any that is any correct equation, we may get the same answer. Okay. So it is also a important problem. Okay. It's a 2 mark question. And the third one, you see, a series RLC circuit consists of 50 ohm resistance, 0.2 Henry inductance, and 100 microfarad capacitance with the applied voltage of 20 volt. Okay. Determine the resonant frequency, quality factor, lower and upper cutoff frequency, and bandwidth of the circuit. Okay, so similar to the first problem. So here for different data, they may ask the thing. Okay, so by in series RLC circuit, 50 ohm resistance. What is this 50 ohm? It's a value of R. Okay, the first one you have to write the given data. R is 50 ohms. Okay, and the inductance is 0.2 Henry. L equal to 0.2 Henry. And the capacitor C equal to 100 microfarad. So the capacitor C equal to 100 microfarad. Okay, and the applied voltage is 20 volt. So the applied voltage V equal to 20 volt. Okay, so these are all the given data. So by using these data, we are going to calculate the four things. One is resonant frequency, quality factor, lower and upper cutoff frequency, bandwidth. Okay, so already you know the formula in order to calculate these things. Okay, so what is the first one? The resonant frequency omega naught is 1 divided by square root of LC. Okay, but here the L is 0.2. What is the value of C? 100 microfarad. Okay, so micro means you know 10 to the power minus 6. But 10 into 10 to the power minus 6, you just substitute and find out the answer. So it is a 707.1 radians. Okay, so this is the resonant frequency in radians. Okay, if we want to calculate the resonant frequency in hertz, means this omega naught divided by 2 pi. Or you may use F naught equal to 1 by 2 pi root LC. Okay, so if the omega naught divided by 2 pi, we will get 112.53 hertz. Okay, this is the resonant frequency in hertz. This is the resonant frequency in radians. Then the next one is we have to calculate the quality factor. So you know the formula for the quality factor. Okay, there are three formulas there. One is omega naught L by R. Another one is 1 by omega naught R into C. Another one is 1 by R into square root of LC. So we may use any one formula in order to find out the quality factor. So by here I am using the first formula omega naught L by R. So what is the value of omega naught? We calculated as 707.1. And what is the value of L? It is 0.2. Divided by what is the value of R? It is 50. So you just substitute and find out the answer. It's a 2.82. Okay, so already you know the quality factor has no unit. It is a just number. Okay, so quality factor we derived. Okay, then the bandwidth we have to calculate. So in order to calculate the bandwidth, already I told that is in order to find out the bandwidth, we may use the formula, or it is a difference between upper cutoff frequency and lower cutoff frequency. So we may use any method. Okay, so in this the bandwidth is said to be, what is the formula for the bandwidth? R divided by 2 pi L. So substitute the value of R and L. So we will get the answer 39.78 hertz. Okay, this is the bandwidth in hertz formula. Okay, so then we have to calculate lower and upper cutoff frequency. So the lower cutoff frequency, okay, formula, you know what is the formula? 1 by 2 pi minus R by 2L plus 1 by 2 into square root of R squared by L squared plus 4 by LC. Okay, so the upper cutoff frequency is 1 by 2 pi. The same formula, instead of this minus, we have to put plus. Okay, so in this, we calculated the FL is equal to 94.39 hertz, and the upper cutoff frequency is 134.178 hertz. Okay, so if you are subtracting these two things, means we will get this answer. Okay, that is also another one method in order to find out the bandwidth. Okay, so this is a similar type of problem with different data. Okay, and the third one, so here it is a 2018 question. So this question is somewhat different. Okay, since the given data is different. Okay, so in the previous three problem, the value of RLC is given, and the question is to find out the resonant frequency, bandwidth, then quality factor, what is the lower and upper cutoff frequencies. Okay, but here there are only two data are given. So what are the given data? You just see quality factor is given. So quality factor equal to 250 given, and at the resonant frequency is given. Resonant frequency is 1.5 megahertz. Okay, so here the given data is different. Okay, so by using these two data, how to find out the bandwidth and its half power frequency. Okay, so it is a somewhat different problem. Okay, so you see, so first one we have to write the given data. So what are the given data? Two data given. One is the quality factor. What is quality factor? The quality factor is given as 250. Okay, resonance at 1.5 megahertz. So what is this 1.5 megahertz? It is a resonant frequency formula. Okay, this is the resonant frequency given in hertz. Hertz means it is a F naught, not omega naught. Okay, so it is an important thing. So here the frequency is given in radians, means it is omega naught. But here the frequency is given in hertz, so it is said to be the F naught. So F naught equal to 1.5 megahertz. So these are all the two data. So what is our question? Our question is to find the bandwidth and half power frequencies. Okay, so the first one, so we have to calculate the bandwidth. So already we know that the relation between quality factor, then this resonant frequency and bandwidth. So this is the formula. Now this is the relation between quality factor, resonant frequency and bandwidth. So the quality factor equal to resonant frequency divided by bandwidth. So but from this quality factor value, you know, F naught, you know, we may rearrange this equation in order to find out the bandwidth. But from this, the bandwidth can be written as F naught divided by Q naught. And F naught is 1.5 megahertz. So mega means 10 to the power 6. Divided by the quality factor, it is 250. So you just substitute the value and find out the answer. So the bandwidth is 6000 hertz. Okay. So here the F naught is in hertz. So that's why we will calculate the bandwidth is also in hertz. So 6000 means, so we will write in engineering term, 6000 means it is a 6 kilohertz. Okay. So bandwidth we calculated. Okay. And the next one, here the question is we have to find the half power frequencies. Okay. So what is half power frequency? There are two half power frequencies. One is the lower cutoff frequency, another one is the upper cutoff frequency, FL and FH. FL means lower cutoff frequency, FH means upper cutoff frequency. So this is the formula for lower cutoff and upper cutoff. So the difference between these two formula is here minus, here plus. Okay, except this one, the same answer. This is the lower and upper cutoff frequency. So in order to find out this lower and upper cutoff frequency, we should know the value of resistor, inductor and capacitor. Okay, but in this problem, so there is no value of R, L and C. Okay, so only we are knowing the value of quality factor and the resonant frequency. From this given data, so we have to find out something and we have to substitute in this formula. Okay, so but here the value of RLC. Okay, how to calculate the value of RLC means you just see. So here you know the formula for the quality factor. What is the formula for the quality factor? Omega naught L by R. Okay, but instead of this omega naught, we may put omega naught is said to be 2 pi f naught into L by R. Okay, but here you know quality factor you know and f naught is you know, right? But from this substituting the value of q value and f naught value, L and R is unknown. Okay, so you substitute the given data and rearrange the equation and find out the value of R divided by L. Okay, but from this the R divided by L is calculated as 37,700. Okay, so you take this is some equation. Okay, this is the ratio. This 37,700 is a ratio of resistor by inductor. Okay, this is the one thing. And another one, you know the resonant frequency formula. So the resonant frequency in hertz, that is f naught formula is 1 by 2 pi root LC. Okay, 1 by 2 pi root LC. But from this f naught you know, but you don't know the value of this L and C. Okay, so that's why here you just give this root LC in left side and f naught to the right side. So root of LC equal to 1 by 2 pi f naught. Okay, so taking square on both sides, so we will get LC equal to 1 divided by 2 pi f naught the whole square. So but from this, the 1 divided by LC value we calculated as some value. It is a 8.82 into 10 to the power 13. Okay, so 1 divided by LC value we calculated. But you see the formula for FL and FH. But in this formula for FL and FH, there is a term R by L is there. Okay, you see R by L, here also R by L is there, and here 1 divided by LC term is there. Okay, in order to, that is using this quality factor formula and F naught formula, so we derived the ratio R by L as well as this 1 by LC. Okay, so but directly we have to substitute the value of this R by L and this 1 by LC in this lower cutoff frequency and upper cutoff frequency. We will calculate the answers. Okay, but you see FL equal to 1 by 2 pi, this is the formula. But instead of this R divided by L, okay, instead of this R divided by L, we have to put the value as 37,700. Okay, so here and here. Similarly, instead of this 1 divided by LC, we have to put 8.82 into 10 to the power 13. But if you are substituting and if you are calculating, the answer means we will get the lower cutoff frequency is 1.4969 megahertz. Okay, this is the thing. Similarly, the FH value calculated as 1.5029 megahertz. Okay, always the upper cutoff frequency is greater than the lower cutoff frequency. Okay, so in this method, we have to calculate this problem. Okay, so this is somewhat different problem. Okay, so in the first three problem, R, L, C value directly given. So directly we substitute in quality factor, bandwidth and half power frequencies. But in this problem, in May 2018, in this problem, quality factor and resonant frequency is given. Okay, by using these two value, we have to find out the value of two things. Okay, what is the thing? R by L and 1 by LC. Okay, so how we are calculating this ratio R by L means we have to write down the Q formula. In this Q formula, this Q and F not given. So it's substitute, you just rearrange and find out the value of R by L. Similarly, in F naught equal to 1 by 2 pi root LC formula, you know. But from this, you just substitute, rearrange and find out the value of 1 by LC. Okay, and these two ratio, if you are substituting in FL and FH means we will get these answers. Okay, so these are all the problems related with the series RLC circuit. Okay, so these are all the very important problems. It's a repeated problem. Okay, every time these type of questions they will ask. Okay, so you just learn. Okay, thank you. Thank you for watching.